Chemical formulas. So chemical formulas are very useful. They are a great way for us to shorten the names of our different molecules, especially because some names can get very, very, very long. So looking at these, there are two types of formulas that we really use, and we should never confuse them. One we use more often than the other. Those are the molecular formulas. We use it the most because it shows the most exact number of atoms of elements in a compound. The other kind of formula that we have is the empirical formula. It's not used as much because it only tells us the most basic ratio of atoms of the elements in a compound. Because the empirical formula is the most basic ratio of the elements, the molecular formula will always be a multiple of that. Now, this can be a multiple of 1, so it will look the same because anything multiplied by 1 is itself. Forensics uses empirical formulas and molecular formulas quite a lot because we start out with our percent composition, go from the percent composition to the empirical formula, and then go from the empirical formula to the molecular formula. We are going to go over how to do all of this. An example of an empirical formula is CH. The ratio 1 carbon to 1 hydrogen can't be simplified any further. However, C2H2 is a molecular formula. It shows that we have 2 carbon atoms and 2 hydrogen atoms in this compound. It is also the second multiple of CH. Benzene, which is C6H6, is the sixth multiple of CH, and it is another molecular formula. It's really important to point out that C2H2 is ethane, and it's not going to be the same compound as benzene, even though they share the same empirical formula. So how do we calculate that? Well, in order to find the empirical formula, we must always be given the percent composition of elements in the compound. Because it's percent composition, it will always add up to 100. This example gives us 25.9% nitrogen and 74.1% oxygen. The first thing we need to do is to compare our percentages to grams. Since percentages are taken out of 100, we can assume that out of 100 grams, 25.9 grams are going to be nitrogen and 74.1 grams are going to be oxygen. Since we have this in grams, we actually want to convert this to moles. Here, grams to moles, we're going to use our molar mass. The molar mass of just nitrogen is 14.101 grams of nitrogen per 1 mole of nitrogen. For oxygen, this is 16.00 grams oxygen per 1 mole of oxygen. When we divide 25.9 by 1401, we are going to get 1.849. For oxygen, 74.1 divided by 16.00 will give us 4.631 moles of oxygen. Remember, grams of nitrogen canceled, and so did grams of oxygen. Because empirical formulas are the simplest whole number ratio, we have to get to a whole number. These two are not whole numbers, they're decimals. So to solve this, we are going to divide by our smallest number. In this case, we're going to divide by 1.849. At the top, this will give us 1 mole of nitrogen. At the bottom, this gives us 2.5 moles of oxygen. Sometimes dividing by the smallest number will give you all whole numbers. In this case, that didn't happen. Now we have to multiply by the smallest number that does give us whole numbers. If we multiply a decimal of 0.5 by 2, we will get a whole number. So we multiply 2.5 by 2 in order to get 5 moles of oxygen. Our moles of nitrogen also have to be multiplied by 2 because everything in our compound must be multiplied by this number. 1 times 2 will give us 2 moles of nitrogen. This 2 and this 5 are going to be our subscripts for their respective elements. So when we write our empirical formula, we will have N2O5. Now, because a lot of students really struggle at this point, I've come up with something called the magic box. After we go over the steps, I'm going to show you the magic box. Our first step was to convert from grams to moles. We know that since percentages are taken from 100, we can say that in 100 grams of this compound, we had this much grams of nitrogen and this much grams of oxygen. This is how we got grams. Then we converted from those grams into moles by using our molar mass. Then we divided by the smallest amount of moles. So this was the number that was the decimal we calculated. Now, in the example, that didn't give us a whole number, so we rounded to the closest decimal in the magic box. In our example, this was actually already 2.5, and as you'll see in just a minute, 0.5 is one of the decimals in the magic box. We multiplied by 2 in order to get 5. Here is our magic box. As you can see, 0.5 is the decimal that we had in our first example. We multiplied by 2. But if you have any decimal, you can easily round it to whichever of these 7 decimals is closest. Whichever one of these you pick, you will just go to the right to find the number you multiply by. Now, to find our molecular formula. In order to find the molecular formula, you must always be given the empirical formula, or a way to find it, and the molar mass of the compound you are finding. Our example here is to find the molecular formula of a compound whose molar mass is 60.0 grams per mole and whose empirical formula is CH4N. The first thing we need to do is find the molar mass of our empirical formula. Our empirical formula, CH4N, comes to a molar mass of 30.052. What we're going to do is we're actually going to divide the given molar mass that they give us, our 60.0 grams per mole, by this molar mass of our empirical formula. Now, we usually do have to calculate this. I didn't walk through the steps because we've already been over that. We take this, put it on the bottom, and do the division. This should always give you a number that is super close to a whole number. For example, we get 1.997. This rounds very closely to 2, and therefore we're going to round it up to 2. Now that we have that whole number, we are going to multiply our empirical formula by the number 2. This will give us our molecular formula of C2H8N2. Let's review those steps. First, we determined the molar mass of our empirical formula. Then we divided the molar mass of the compound by the molar mass of the empirical formula to get a whole number. This was rounded to the nearest whole number and then multiplied by our empirical formula. Here is an example of finding the empirical formula and using that to find the molecular formula. We'll go over this in the next video.